Hey there, Flutter enthusiasts! Welcome back to another exciting tutorial on Flutter and Dart. In today's video, we're going to unravel the mysteries behind three important Dart types: var, object, and dynamic. By the end of this video, you'll have a clear understanding of how these types differ and when to use each one. What is var? Let's kick things off by discussing the var type. In Dart, var is a keyword that represents a dynamically typed variable. This means that Dart will automatically infer the data type based on the assigned value. It's convenient when you're dealing with values of different types. However, keep in mind that the type of a var variable can change during runtime. In this code snippet, we declare two variables, name and number. We print their values, which are John and 42, respectively. However, when we attempt to assign the string Bob to the variable number, Dart will raise a runtime error, as the variable number was originally assigned an integer and cannot be changed to a string. What is object? Moving on to the object type. In Dart, object is the root class for all other classes. This means that any data type in Dart can be assigned to an object variable. It's like a universal container that can hold any value. But here's the catch: since object is so general, you won't have access to the specific methods or properties of the assigned value without typecasting. In this example, we assign the string hello to an object variable called value. While we can print the value without issues, trying to call string-specific methods directly on value will result in a compile time error. To access those methods, we must cast the value to its proper type, which, in this case, is string. This illustrates the flexibility of object but highlights the importance of typecasting for precise data manipulation. What is dynamic? In Dart, the dynamic type is incredibly flexible. When you declare a variable as dynamic, you're essentially telling Dart to allow any data type to be assigned to it. This can be particularly useful when working with data of uncertain or varying types, such as when dealing with external APIs or dynamic data sources. However, this flexibility comes with a trade-off. Unlike statically typed variables, like int or string, dynamic variables don't undergo type checking at compile time. Dart defers type checking until runtime when you use dynamic. This means that errors related to type mismatches may not be caught until your code is actually executed. In this example, we start with a dynamic variable called value that can change its type during runtime. It initially holds a string, then changes to an integer, and later to a list and finally a boolean. It can take on any type during runtime. But here's where caution is needed. We attempt to call a method, some unknown method, on the value. Dart static analysis doesn't warn us, but during runtime, it may lead to an error. So, while dynamic provides flexibility, use it judiciously, especially when working with methods that may or may not exist. Congratulations! Now you know to use var for convenience, object as a universal container, and dynamic for flexibility. Best of luck with your Dart programming.